In this tutorial, we'll work out the questions on homework number 401. The first section asks you to identify if the relation shown in the table is a function or not a function. So what we're looking for here are repeating x values with different y values. All right? So it's okay to repeat an x value, but not if it has a different output. So you want to make sure that you're looking for both of those things. So here in the first table, we have all unique x's. But here in the second table, so that one is a function. In the second table, you'll notice that we have a repeat with the -2 here, and it has a different output. So that is not a function, because it has a repeating x value with a different y value. Here we have all unique x's, so that one is a function. And for our third value here, for our fourth table here, we have all unique x's, so again, we have another function. So only one of them does not suffice to be a function. Let's take a look at the second section of this homework, which is to identify the solution to the system of equations. Now remember, a solution is the point of intersection. So our point of intersection here for this question is 1, 2, -3, +2. So -3 on the x, +2 on the y. For this question here, our point of intersection is 1, 2, 3, -4, +1. And for the fourth question, you'll notice down here that we have an overlap in our lines. So if these two lines are overlapping, that means that they have infinite solutions. So you can use the math symbol, or you can write it out in English, infinite solutions. Okay, let's take a look at the next section here. Find the rate of change from the given points. Now remember, rate of change is a slope, and the slope formula is y2 minus y1 over x2 minus x1. Typically we call it a subtraction fraction, but we take our second y and our first y, and then we take our second x and our first x. 2 minus 2 is 0, and 6 minus 1 is 5. A reminder to you, oops, my marker changed colors there. A reminder to you that anytime your fraction has a 0 in it, you have to interpret it, right? You either have to say, is it 0 or is it undefined? And a 0 in the numerator is 0. Let's do our subtraction fraction for the second one. Y minus y is 2 minus 9, and x minus x is 3 minus a -3. Watch your double signs there. So we're going to get -7 over 6. So our answer here is the fraction, -7 over 6. Last one, set up your subtraction fraction, y minus y. We've got a double negative up there, and x minus x. So anytime you have two negatives in a row, you can change it to a positive. So that's 6 over 0. But a 0 in the denominator is undefined. 0 in the denominator is undefined. Alright, let's check some of our exponent rules here. When you multiply like bases, you keep the base the same, and you add the powers. It says to write using exponents, so we leave it as a power. Now don't forget in this second one here that second 6 has an invisible 1 power. So keep the base, add the powers. Now this one here we have some coefficients, so those actually do get multiplied. But our like bases of r stay the same, and we add the powers. Now the problem with this one is the power is not positive. So in order to make it positive, we need to take the reciprocal, right? We need to put a 1 on top, and then that power becomes positive. So that x to the 4th. All right, we're going to do the same thing with question number 9. Take the reciprocal and make the power positive. So the second one here says evaluate if possible. So 1 over 3 to the 4th is correct. But then we need to compute 3 times 3 times 3 times 3. 9, 27, 81. Use your calculator if you need to. 1 over 7 to the positive 2 is correct, but evaluate if possible, and we can. Now be careful with this last one here. Only the m has a negative power. The 9 technically has an invisible 1 power. So the 9 stays on the top, and the m squared goes to the bottom. All right, row 10 here. When you divide like bases, you keep the base, subtract the powers. This is a tricky one. 4 minus minus 6. So that's what we're doing. 4 minus a minus 6. We got two negatives. That makes a positive. 3 to the negative 5th. Oops, 3 to the negative 4th. But that can't be negative, so it's 1 over 3 to the 4th. And earlier, we figured that out already. So 3 to the 4th is 81. 5 to the 6th divided by 5 to the 6th is 5 to the 0, and anything to the 0 power is 1. Down here, we're going to get 3 to the negative 4th. Again, no negative powers. And we figured 3 to the 4th is 81. A to the 3rd. That's 8 times 8, which is 64, and then 64 times 8 again. Get my calculator, is 512. All right, we're doing great. Last section. Let's solve some equations here. So I need to clear my parentheses first. So this stays the same. The 8 stays the same. But negative 1 times 12 is negative 12. And then divide by 3. That's what 1/3 times 12 is, or you can use your calculator. Negative 1/3 times 12 is negative 4. And the w comes along. And then negative 1/3 times 42 is negative 14. And then I got to copy the rest of the question. I've got some like terms here that can go together. So I'm going to rewrite here. Negative 61 equals negative 6 minus 5w. I'm going to add 6 to both sides. And let's see, negative 61 plus 6 is negative 55. And this is looking pretty good. Divide both sides by the coefficient. And looks like I'm going to get positive 11. That wasn't so bad. Alright, now we got some double distributing here. 5 times both of those. Be careful. This is negative 3 times both of those. So nothing to do over here. Negative 3 times c, and negative 3 times 8 is minus 24. Got some like terms here and there. So 45 minus 24 is 21. So nothing to do here. 7c plus 21. So I'm going to subtract 21 from both sides. I'm going to get negative 63. And divide both sides by 7. And I get negative 9. Alright, let's take a look at the last two. Okay, no distributing here, but this time I have variables on both sides of the equal sign. So I'm going to shrink this up first and get negative 23. And now to get my 8's together, I'm going to have to subtract one of them. So I'm going to choose to move the lower one, keep my variable positive. Now I got to move my constant. Use my calculator so I don't make a mistake. Okay, final step, divide by the coefficient. All right. Okay, last one, we've got some double distribution here. Negative 6, and negative 6 times minus 3 is positive 18. Now let's do the other side. 5 times 4 is 20. 5 times minus n is minus 5n. Alright, again, my letters are on different sides, so I need to use an inverse operation. Now you can move either one, but I'm choosing to move 6 because that will make my variable positive. And it's at 1n, so I'm going to leave the 1 off and just write n. And we are done. Fantastic. Okay, good luck.